In this video, we are going to do step-by-step tutorial using very popular Raspberry Pi or Raspberry Pi microcontrollers. And Scott is going to help us with these examples, which are very simple, but they will help you to start using this microcontroller. Is this what we are going to do today, Scott?
That's my plan.
Okay, so I think let's start. What we are going to use? We are going to use two different boards today, and one kind of setup which is going to help us with the examples, the keyboard. What do you have?
All right, so right here on my desk, I have the Raspberry Pi Pico 2W. And then next to it, I have an Adafruit macro pad that is an RP2040 base. So this is the older microcontroller from Raspberry Pi. We'll get it locked in there.
But they are basically very similar, correct?
The RP2350 is definitely an evolution of the 2040. But the CPUs that are in it and the amount of RAM it's twice as much RAM, and the CPUs are significantly faster.
But the way how we work with them is similar. That's what I mean.
Yes. Yeah, so we'll be using CircuitPython today, which is a version of Python designed for microcontrollers. I work for Adafruit, and I work on CircuitPython. And one of the benefits of CircuitPython is that the way that you use it across boards is very, very similar. So if you're using a macro pad or you're using a Pico with a 2350 on it, the process is going to be very similar. It gets a little bit more different if you don't have native USB, but today we're just doing native USB on both of these.
So what is the first step what we need to do? I guess we need to somehow put the CircuitPython on the board.
That's right. So neither of these boards come loaded with CircuitPython. So the first thing to do is to get into bootloader mode. So I'm just gonna set the macro pad off to the side for now. And what I'm gonna do is there's only one button on the Pico here, and I'm gonna hold it down while I plug it into my desktop. And the USB cable can turn a little bit, but so now we get this drive that's RP2350.
I would like to point out, so by default, if there is something already on the board, it will start the application or something. But
that's right.
To be able to see it as a storage, we need to press the reset twice, correct?
So what you're doing is this is labeled boot select.
Boot select, okay.
You hold boot select down and then plug it in, and that'll go into bootloader mode, which will then have this RP2350 drive. If you're on an RP2040, you hold boot select down during reset, and it will come up as an RP2, slightly different name, but same idea.
Okay.
Device.
Okay. So once we see this as a storage, okay, these are the files what are.
Yeah, so this is actually a fake file system. And what you do is we're going to download a UF2 file and drag and drop it onto here, and then it will immediately flash to it. There's not actually a file system under it. Sometimes people get confused about how big it is. It may look bigger than it actually looks like it. So this is the CircuitPython.org webpage. You can go to downloads here, and we have 581 boards currently that we support. These two look very similar, but these are actually the Pico 1s, not the Pico 2s. So we're going to search for Pico 2, and so we're going to select Pico 2W. We're going to do the latest version of CircuitPython, which is 9.2.3 currently. And you can see it here. It says download UF2 now. We actually have multiple languages. So this changes the language of the helpful text and error messages. But it doesn't change like the actual Python code that you're writing. So we're going to hit download. We're going to do it into downloads. And it's done. So now we're going to go to downloads, sort by modified to find the latest file. And here is Adafruit CircuitPython Raspberry Pi Pico 2W English 923, and we're just going to drag it over to the drive. And I missed the drive. And we're going to say copy. Now it will copy it all over, it'll flash the device, and then it will automatically reboot once it's done. Which, if you're on Mac, may cause a pop-up to say like the drive was disconnected when it shouldn't have. But the device knows when it's gotten all the data that it needs.
Yeah, even in Windows, the drive will disappear.
Right. So the bootloader knows when it got all its data. You don't. The host OS doesn't know that.
Oh, so it disappeared now. See?
Like,
it says,
yeah, so it's gone.
Yeah, it says CircuitPython.
Yeah, CircuitPy is the default name of the drive. So if we open this up, we'll see that we have some default files. And we have a code.py. So this is your Python code. It lives on the device, and all of the processing happens on the device. So all we have to do is...
Just clarify before we continue. So basically what we did, we upgraded firmware on the board. The firmware is basically the code which enables us to run the Python on the board. And to access to our board or change the code, we can do it directly through this, through this mounted storage. Because now, again, the board is mounted as a storage, but it looks a little bit differently as if it is in the boot mode.
Correct. So you'll see different files. This is actually a real file system as well. So from Python, you have access to this file system too. Yeah, there are some CircuitPython boards where we don't have native USB, and there's other ways to do that. But today we're going to focus on the native USB experience. So once you've gotten it and it pulls up, there's a code.py. So you can just double click code.py, and it pulled up in my text editor here. And you can see that we default to a hello world. Now, in something like Arduino, you would have a serial terminal kind of in your editor, but this is just the editor that I have. And the way that I like to do it is I like to have a second window. So I have my console here. And I'm going to do the serial connection separately. Just try to position them next to each other so we can see both. So I like to use, you could use something like Screen, but I prefer a program called TIO because it will automatically reconnect when the device comes back. I do a lot of development and my USB comes and goes. And I'm on Linux here, so I'm doing dev serial by ID, and then it has the name of the board in there, which is nice. And now it's telling me auto reload is on. Simply save the files over USB to run them, or enter, press enter to.
Okay. Again, I would like to clarify. So basically, what we did, once we have the board mounted as a storage, we can also connect to our board through USB as a serial port. So
that's correct.
So basically, the firmware what we created, it also creates the serial port. Connect?
Yes. Okay. Yeah, it creates a composite USB device.
Okay.
Meaning that it does a lot of different things. So as we'll see later, it actually allows you to act as a mouse and keyboard as well.
And so basically, this serial port we can then use as a terminal to work directly on our board. And what are the settings for this serial port?
It's 115/200 speed, which is the default for TO, and I think is for Screen as well.
Okay. So once we have the CircuitPython on the board, it is connected to PC. We can see the drive. Then important is to open Serial Console, any software what people are using. Use these default settings 115/200 or what is it, and we will connect to the board. These are the two windows that we can see right now.
Right. Okay. So the serial is where you'll see your error messages and things show up.
Okay.
So if we do something really simple and I'm going to hit Control S to save. And you'll see that it detected that I saved the file and it reran it. We can see hello world, but we could say hello Robert instead and save it and rerun it again.
Okay, so you are directly changing the file which is in the mounted storage, and automatically after you save it, it is executed. That's correct.
Yeah. Yep. And in fact, even well, let's do Blinky. So instead of doing print, we're going to import a couple things. So this is Python. So board is a module that has board specific things. In fact, what I like to do is if you hit enter at this point, you can get into what's called a REPL, which is a read eval print loop. It's a Python thing. And so I can type Python code here. It doesn't get saved, so it's just good for like exploring things. There's a Python function dir, so we can see all the things that are on the board module. So we can see all of the different pin names that are available. We can see that we have an I2C available and also an LED. So that's really helpful if you like need to know like what the name of something is. You can also do help modules. And this will list all of the modules.
Oh, because we downloaded the firmware directly for this board, all the files and all the settings and everything is related specifically to this board what we are using.
That's right. That's right. Yeah. So, which makes it really easy to do something like a Blinky example, which we'll do in just a second. Because we can just do board.led and we don't care what pin it's connected to. We've already kind of designated it as the like board's LED. And we're also going to use a thing called digital in out, which is in B, C, it's over here. So digital IO is in this big long list of natively supported things. So I'm going to shrink it and I'm going to hit Control D to get back to the mode where I'm running code.py. If I saved the code.py and I was in the REPL, the code.py would not rerun automatically. Yeah, it only happens if you're doing code.py. So import board, import digital IO, and we're going to call, it's auto-completing for me. I have GitHub Copilot turned on. So that's what the suggestions you're seeing are. So digital IO, digital in out on the board LED pin. Digital in outs are inputs by default, so we need to set the direction. You can also do switch to output, and you can give it a default direction. And then we're going to do a loop, and we're going to say it knows what I want. Let's do it this way. Actually, we'll do false. And then we'll do time.sleep for half a second. We'll set it to true. And I forgot to import time, so we can put time up here too. And I'm gonna hit save. And now
show me the board.
Sorry.
Ah, yeah, it's working.
So the LED is here. Sorry. This board is smaller than the other one, so is that in focus? So that's our LED blinking, and what I could do, for example, is
maybe you need to zoom out a little bit because it's not in focus, or I don't know why.
Oh, let me. The problem is the USB cable is causing it to roll. Get my hand out of the way and I'll hit.
Ah, okay, perfect.
Better, yeah. Great. So I'm going to change it to 0.1 and I'm just going to save again. And we'll see that now it's blinking faster. So CircuitPython's edit test cycle is super, super quick because we're not actually flashing kind of a full firmware. We did that at the start with a drag and drop. What we're doing now is we're just writing code.py, and then it all gets interpreted on the device itself. So it's super quick.
I have a question. So when you listed all these functions or features what we can use, is there some kind of help to see the examples how to use them? For example, digital in out. Is there?
Right. So there's a couple good resources. They don't live on the device itself, but there's if you go to learn.adafruit.com and then look for CircuitPython Essentials, there's this guide here, and it has examples for all these basic things. So here's how to do digital in out. So here's based on a switch, set the LED value, for example. And lots of resources here about the basic functionality of CircuitPython. And this is where I pulled from for some of the examples that we'll go into.
Okay, so we have the LED. What is the next example? So this is output. Well, so this is basically output, pin output. We control pin output. Now maybe input.
That's right. Sure. I'm gonna check my reference here too. I prepared some examples ahead of time. The next thing I wanted to do was NeoPixel Blink because I want to switch to the macro pad because it's got switches on it for input. So let's do NeoPixels and let's introduce also how to manage libraries.
Okay. Again, I'm sorry for interrupting. So for everyone who would like to continue or who would like to follow what we are doing together with us, you created this post on your website.
It's on Adafruit Playground. Yep.
So anyone can copy code and paste it.
Yep.
And also before we continue, what NeoPixel means?
So NeoPixel is a Adafruit trademark for an RGB LED, so it's got red, green, and blue in it, and it has a particular controller that's known as the WS2812. So NeoPixel is the Adafruit branding for that device.
For RGB LED.
An RGB LED string, so it's multiple RGB LEDs, and there's a certain way that like you can communicate to those.
Okay. Can we find it? I'm just curious. Can we find it?
NeoPixel on the Adafruit website?
Yeah.
There's also like a NeoPixel Uber guide. So here's some pictures of the devices here.
So these are like addressable LEDs, or these are standard LEDs connected to special controller?
These are addressable LEDs because they have the controller in the device itself. And they get chained. So you can have like big long strips, which I guess is what makes them addressable.
Okay.
So I'm just gonna quickly get CircuitPython. I think CircuitPython's on here, but I'll show you how to do it on the macro pad. So there's a USB port here, and this rotary encoder switch is the boot button. So I'm going to hold the rotary encoder down, and I'm going to plug it in, and then we should get another drive, which we did. So RPi RP2, so that's for the RP2040. We can see we have the same info UF2 and index.html files that we did before. We'll go back to downloads, we'll hit back, and we'll look for macro pad. So now we have the RP2040 macro pad. We'll just download the UF2, save it to downloads, and drag and drop it again. Yes, I have a lot of downloads. Drag and drop the file onto the device, copy here. And it's copying over, and then once it's copied over, it will restart.
So the drive will disappear, and we will see the...
We'll get a CircuitPy drive back. Why it's so slow? All right. So My demo is currently running. That is at the end. So I'll show you how to reset the drive here. So it's a different device, so my serial terminal's gone. So Control TQ is how you get out of it in TO. And now I'm just gonna tab complete to get the macro pad.
Because
we can
it's
see
different
that
serial port.
it's a different serial port, right?
Yeah.
It's based on the like board name, so it will change. I'm gonna Control C, and I actually want to just I should have a backup of this example, so I'll show you how to if you have ever had file system issues where it says it's corrupted or something, you can do import storage, and then storage.erase file system, and this will kind of put you back to the blank slate CircuitPy drive and get everything fixed up. So it disconnects because it will redo the file system and then restart so that you start afresh again. So if we go to the CircuitPy drive, you'll see it looks exactly like
before.
The one before.
Completely empty. Okay.
Completely empty with the Hello World example. So instead of me typing it out, let's pull up our notes. And for NeoPixel Blink, I'll just say copy code. And then copy and paste it in here. And hit save, and we'll see that, it says there's no module named NeoPixel. So this is, we have like low-level NeoPixel support within the CircuitPython firmware itself, but then we have a bunch of libraries that you can load onto your device. So I want to show you how to do that. So you go to github.com/adafruit/adafruit CircuitPython bundle. And I guess I could go to I have a link there too. So 12 hours ago, this is just a zip file of all of our CircuitPython, Adafruit created CircuitPython libraries. So I'm going to download Adafruit CircuitPython bundle, the Python version. NPYs are like a condensed kind of binary packed version that is good for small boards. It just takes a little less memory to import them than it does the regular Pi ones. But the nice thing about the Pi files is that they're still Python source code. So I'm going to download that. And then once it's done, I will extract it.
So this is basically some kind of extra code to save people time.
Yeah, and like if you have a particular I2C or SPI device that needs a driver, like this is where those drivers live. So let me open it up in downloads. So you can see here when I was doing this, 116 is from when I was testing it before. So hopefully it hasn't been broken since then. So if I just open the live folder, you can see there's certain folders here, and then there's also just plain Python files. And we want NeoPixel.
So these are the drivers?
These are the drivers and helpers. And I just hit sort by name because I was still sorting by time. So there's a NeoPixel Pi here, and I'm just going to drag and drop it over to CircuitPy again. And now that it automatically reran, and now it's running. And if we look at the board, back it up, readjust it, we'll see that all of the NeoPixels in the macro pad are now blinking off and on red. Is that get it in focus again? I have a messy desk.
So now when we have a look on the storage, then there will be two Python files, correct?
That's right. So if we pull up CircuitPy, we can see that there's code.py here and neopixel.py. You could actually move this into this lib folder if you don't want to like clutter the root, but it works in the root or in the lib folder just fine.
Okay. Does it? It doesn't flash. Yeah, it's not flashing red anymore.
Yeah, so I think what happened here is that like maybe it tried to run in the middle of moving the file, which it shouldn't have. If we Oh, you know what can happen is that the host OS is doing the manipulation of the device, and the host OS may not write it all the way immediately, which leaves CircuitPython in this like intermediate state. So now it's working because the host OS has decided to finish flushing. This is a problem with USB sticks, like USB devices, and why they tell you to eject before you take them out is because there is some caching that the host OS is doing.
So basically, the problem was you moved it in the middle of when it was doing something, and then during the process of copying, basically that's when the problem happened.
Right. So when I told like Linux like, hey, move this file from here to here, it did half the work and then stopped. And then later on went back and finished doing it, and now it's working.
Okay.
And then the other thing I wanted to show is that the screen on the macro pad here, because we have a specific firmware for this device, it also is running the screen automatically, and it's showing us the same thing that we're getting on the serial terminal. So even if we don't have the serial terminal, we would see a little bit of the output here as well. And we also get this status bar here that we're like running code.py, and this is the version of CircuitPython that we're running. So that's all automatic. If you have user code, you could take over the display if you wanted to customize what it was showing.
Okay.
Anyway, so we're
go ahead.
Moving on to inputs.
But still, I would like to see. So, how do you find out how you can control these LEDs, or how can you use this library? Because let's say I would like to use I2C driver. I need to figure out how to use this I2C driver.
Right.
So we have this LED driver. How do we use it? How can we change the color of the LED? Or
so there's a couple places to look. For NeoPixel, because we do it a lot, it's part of this CircuitPython Essentials. We'll have a tutorial on it with examples here about how you can do fill, which I think is what we're doing now, or you can do array access. Here. The bundle, the zip file that we downloaded, is actually a collection of a lot of different libraries. So, and they have a standard naming. They're Adafruit CircuitPython and then kind of like the short name. So we can go to NeoPixel. And this is the source for this library. This NeoPixel Pi should be the same version that we've got on our device. There is docs passing here. So if we click that and I opened it in a new tab, we'll get the API reference of that class. So you can see here's NeoPixel, here's what the parameters are, here's an example, here's the functions that you can call on it and the property that you have as well.
Okay.
And there's also examples here.
Okay.
And those examples are taken from the repo. So.
Okay, so go into our code. What is inside of our code? The one what we are running right now.
Right. So what we have here
I see.
In code.py is we're filling with black, which is off, sleeping for 5, and then we're sleeping with red. So this is red, green, blue.
Okay, so move FF.
Yeah.
Okay, let's see what will happen. Oh yeah, green. Okay.
So now we're green, and you can do it at what's called a tuple as well. And I should also point out it's not wrapped, but there's a global brightness setting, just because NeoPixels are really bright. So I have the brightness kind of globally turned down. So even though my color is using like the full strength blue, the brightness is scaling all of the components down.
And fill it means basically we fill this square 3x4 with
right. So there's 12 NeoPixels here. If we wanted to do just the first one, so we could just do I was just thinking like, what state is it going to be in? So the pixels object acts like a Python list. So you can say, oh, I just want the first one to be there. So now I'm only blinking this first one.
That looks simple.
Python is a wonderful language and having it on microcontrollers. I mean, obviously I'm biased. I've worked on this for a long time, but Python is great for that.
Okay, let's do the input example now.
Okay, so let's modify this. And so we want to say button equals digital in out, digital capitalization does matter, board dot button. Key 1 is what it's called. And in fact, this is how I use the REPL. So I hit Control C and then enter, and I can do import board and dir board again. And now I can see the names for this because we're on a different board than when we did last time.
Yeah.
So now we can see we have key 10, key 11, key 12, key 1. We also have stemma I squared C.
And button, that's the button on the board? Or?
And button, which I think is the rotary encoder button. I was going to do
No,
P1,
it says encoder switch. There is probably a different one.
Oh, yeah. I don't even know where all the buttons are. There is a button on the side. It might be reset. I don't know what it could also be. So these names can mean the same thing. So if we do board dot button, it's actually
you are right.
Switch. So button is kind of like our standard name, just like LED. And yeah, that's a trick. Is that pins will tell you like their canonical name if you have them printed out like that. So yeah, button is encoder switch. So if we just write the generic example, and then I think we have to do pull up. We can also do button pull equals pull up. And then we can say...
So this will enable pull up resistor on the button?
That's right. That's right. Yeah. So we can say if button value off. Because if it's pulled up, it's not pressed when it's up. Else. And then we're not going to sleep. We're just going to read it as fast as we can. And we're still in the REPL. And in fact, so this is showing white right now. So CircuitPython has a notion of status LED. So it will change color or blink or not blink and just be on to tell you whether you're in the REPL or if your code finished with it correctly or with an error, or there's also a safe mode that we have as well. So it's white indicates that it's in REPL. So I just hit Control D to get out of the REPL, and now our code should be running. So if I press the switch, the LED turns on, and I let it go, it turns off.
Okay.
Just like that.
That's really simple.
Yeah, so we've got 15 lines of code with some blank lines. CircuitPython is meant to be simple.
What about interrupts? I would like to talk a little bit about this because I mentioned this. Normally, if you have a microcontroller, you would like to use interrupts to save time of the microcontroller or something. Here we are running in a loop. So how does it work in CircuitPython?
Yeah, so CircuitPython doesn't expose the idea of an interrupt to user code. We use it internally for certain tasks. If you were wanting to save power, for example, we have the ability to do deep sleep or light sleep and wake on a pin. You can do that. We also have keypad, which is a class that tracks the key events kind of behind the scenes, so that if your Python code's busy doing something else, you don't miss key presses. But those are more advanced examples that I was planning on covering today.
Okay. So basically, if someone would like to process inputs, the easiest way is just do it in a loop.
Yeah. Yeah.
Okay.
I think so.
What kind of
Yeah, I
example
mean,
is the next what we have?
right. So the next thing that I wanted to do is if I say print down and print up, what will happen is that I'll get a lot of print statements. But I'd like to get it so where I could only get one each time. Because what I actually want to do is I'm trying to get to a point where I can type something in. And I don't want to have to do it repeatedly.
Yeah, and I think
So,
they are reversed. It should say up, no?
yeah. Try not to go too quickly off my notes. So we could say last value equals false. And then if the button value is not, or we could say if is if value now is different than what it was last time, then we actually, it might be simpler to say if it's the same, we just continue. If it's, and then we say value now, because we don't want to read it again. And then once we're done, we say last value equals value now. Right, so it said up once because I initialized it to false, which I guess makes more sense to do true, since that's our default state. So now if I press it down, up, down, up, down, up.
And also color is changing.
Yeah, the color should still be changing. But we're only sending it to the NeoPixel strip once instead of repeatedly like we were. So it may be like pulling the button faster now because we're not doing the NeoPixel, but humans can't tell.
This is also an example how to use serial port, basically. Because we are sending messages to serial port.
To the USB serial port, yes.
Yeah, to USB serial port.
But you don't want to use you don't want to have a host program talking to this directly necessarily, because if you send special bytes like Control-C back down, it does something different. Right?
Okay, so if you need serial port in your application, then we should do it differently. Is there also different serial port?
Right. So CircuitPython has the ability of creating a second serial port that it doesn't touch. That is only for user code. I don't have an example of that today, but it is possible.
But you would use it the same way, like print, yeah? Print and that's it.
No, you would use it more like a UART, where you're reading and writing to it.
Can we just have a look on example? You can find the example, I guess.
Yeah. So
I'm asking because it's one of the most common interfaces what people need to use.
So I happen to know that it is. We have a guide for customizing USB devices in CircuitPython. And let's go to serial. So if you don't want CircuitPy to show up, you can disable the drive. If you want MIDI to not happen, you can disable that. And then this is the USB serial console REPL, which is what we've been looking at, but also the data one. So here so we also have a if there's a boot.py file, we'll run it once at the start. And that runs before USB comes up. So that's a chance for us to change how we look to your computer over USB. So what you would do is you would take this code here and put it in your boot.py.
Boot.py, okay. Oh, there is different kind of file. Okay.
Right.
And it only runs once when you connect it to computer.
Right. right? It only runs when it starts up the first time. So here you can enable both the console and the data. And then
you should see 2 serial ports when it is connected.
You should see 2 serial ports on your computer, and you can reference it. It's through. See this page from. See USB CDC documentation. So there is also docs.circuitpython.org, and this has API information for the native stuff. So there's a USB CDC.console variable here that acts like a serial object, and there's also USB CDC data object that acts like a serial. And then if we look at USB CDC serial, we can see read into.
Yeah,
read
that's
line.
why you said it's not print.
Right.
It's basically a little bit different. Yeah, write, read line. Okay.
And I bet we can do, so if we're in the REPL, let's try something. Import USB CDC. And we actually have a tab completion as well. So if I hit dot and then tab, we can see that there is console. It's a serial object, and then data is probably none. Yeah, so if it gets none, it doesn't show it. But if we do console, we could write hello. I don't know what the 5 is. Oh, you know what? I know what the 5
Number
is.
of characters.
Right. So write returns the number of characters that were written. So we're getting hello written over the console, and then the REPL is printing the 5, which is the return value from write. So yeah, the REPL, this is how I like to use the REPL. It's just a great way to explore the things that you can do kind of before you integrate it into your program. So yeah, if you want to do your own serial transport to the host computer, you do the boot.py stuff that I was showing, and then the data object will be another serial object, just like console is.
Okay.
But over the other link and not messed with.
Okay.
Not doing Control-C. Okay, so now that we have up and down, one of the things we talked about doing is actually acting like a keyboard. And here I am going to reference my notes. So we did NeoPixel on press. Oh, and I forgot. I2C device is another thing we could do.
Okay, yeah, we can do I2C.
Well, how about let's finish our thought, I think, about USB and keyboards.
Okay.
And then we can go back to I2C.
Okay.
So key up and key down is basically what I did. I did it slightly differently. But now this is to typo 1. So I'm gonna snag some of this stuff out of here. So digital I board time, NeoPixel are all the same, but then USB HID. So HID stands for human interface device.
That's USB device, correct? That's kind of a USB driver.
That's right. And so
PC.
when CircuitPython, so when CircuitPython starts up, it's actually a mouse and keyboard already, unless you disable it in boot.py, which you can do. So I'm going to get, let's see. So I'm importing keyboard. I'm importing keyboard US layout and key code. I'm constructing the keyboard object and then the keyboard layout US. So keyboard layout would allow you to say, like, I want to type hello or some word, and it does the figuring out of, like, if it's a US keyboard, these are the codes that corresponds to. I don't think in my example I'm actually using it. I'm just doing keyboard directly, but that's, I snagged it from the example, that's why it's still in there.
Okay, so I would like to clarify. Again, for everyone who is watching, basically what if I understand right, I have never seen this example, but if I understand right, CircuitPython can make this board to look like a keyboard, regular keyboard or a regular mouse. So in Windows, we can basically use this keyboard, which is connected through USB. We can write standard letters, or we can move the mouse. That's basically the example what we are trying to do now.
Right. So I mentioned earlier that it's a composite USB device, meaning that it's like more than one thing. So it's a mass storage device, which is the drive. It's a serial connection for the console, and it's also a mouse and keyboard by default. If the board, like if the microcontroller can do that, which both the RP2040 and the RP2040 and the 2350 can do that.
So now I'm curious, because we only have 12 buttons. So how do you say which button is what letter?
Right. So in my example, I'm just doing one thing. So I'm just going to do it based on the button. If it's down, we're going to press the key code number 1. In my example, I did 1. So if we, okay, so now it's saying, oh, you don't have Adafruit HID. So we do have a helper for this, but I think it's simpler to just show.
So this is another library what we need to download, yeah?
Right, so I'm in the bundle here. So the bundle has all of the Adafruit created libraries in it. And we actually have a Python tool that you can pip install called CircuitPython that can do this for you as well. But I think, you know, it has minimal installs to just download it, unzip it, and copy it yourself. So this time I'm copying the whole folder, not just a single file. And it's been copied over. And if we look here, we're running again just fine. So now if I hit
encoder switch, we should see number 1.
And if I hold it, it does your keyboard repeat, like you're holding it down.
Okay, change it to number 2.
Okay.
How do you know the key codes? Are they listed somewhere?
So if you see, I actually copied this print out of here. So I used dir again, which I had been using in the REPL, just on this key code class. So if I hit save again after uncommenting it, it'll tell me all of the key codes. And I think that if we do keyboard layout, I didn't prep this, but I think is that right? That works. So I don't think this will hold it down. Yeah, so I'm still typing 1. But if I say hello and press it.
Almost.
Yeah, almost. So I use Colmac. So I'm not using a US keyboard layout. I'm using something else.
Okay, okay.
That's why it's not right. It's not right because it's keyboard layout US QWERTY, not Colmac. So take my word for it that it would work. I think there is a Colmac layout that I can do instead of this US layout, keyboard layout, but I don't think it's worth our time. It's Colmac, that's why.
Okay.
But yeah, so that's the nice thing about keyboard layout is that it's doing the, like, I have a Unicode string, and what key codes do I press? That's what the keyboard layout is doing for you. It's also like pressing them in sequence, whereas like the original example with directly to keyboard.
Basically, you can very simply create macros.
Yeah, yeah. So if you want to type things, but if you need to do like 2 things pressed at once, like press can actually do keycode.shift. And I don't know what that'll type, but I think
no, you need to put
something.
a letter A or something, number, or there is
right.
Yeah.
It's like 2 on the top row,
Yeah,
right?
okay.
But it's not 2 on the numpad. So I'm getting @ signs. So you can combine. That's how you do, like, you know, control whatever, control shift whatever. Is you can just provide it on press here.
Okay, I understand. And
okay,
can you,
so let's see.
Can you list the layouts? I'm curious. How do you list the layouts, available layouts?
So I think that we only have US in our repository. CircuitPython HID is where it lives. Adafruit HID, and then it just has keyboard layout base and keyboard layout US. If we go back and look at the thing, this library has ENUS, but check out the expanded library from Neradoc, who's a community member. They figured out how to auto-generate all of the layouts. For example, if you want French, for example. So that's how you would get a French layout. I don't know if they're actually checked in here. And you could actually also do it on the web. So keyboard layout info. Like if I wanted a Colmac, for example, let's see if they have Colmac. Yeah, so they have Colmac here. So I can copy this, go into Neradoc's generator, paste it, and then make a zip bundle for it.
I'm curious. I'm sorry,
Oh,
you
look.
didn't prepare this, but you
No,
know.
it's fine. I'm totally game. It's funny because I've already downloaded it once. That's what the parentheses one is. I've done this before, turns out. So I'm gonna extract, and I'm gonna be bold. I'm gonna extract it, and you can't probably see this. I'm gonna extract it straight to my CircuitPython device, and then it's keyboard layout WinCMK. So in my code.py, it's not an Adafruit HID anymore. Keyboard layout WinCMK, and then I don't know the class name, but if I go to my CircuitPy drive, oh, and it's not the right place. So let's.
But I like to create these kind of examples because it also shows how you find information, and that's what many people need.
Okay, so this is just called keyboard layout. So I'm going to import from that. Yeah, so I should say that I stream deep dives every week on the Adafruit channel. So 2 hours of this, but with people from the chat. And then we want layout. So I'm totally happy to go wherever you. Yeah, tangents and stuff. So let's try the hello example again. And we are working, which is good. Move my cursor back here. Now it types hello correctly.
Perfect.
Whereas before it did. So that's for folks that aren't in the US. Neradoc did an awesome project to have keyboard layouts for other languages. So they're not in the Adafruit hidden libraries, but they are available.
Okay, next example. What do I2C was the next example, correct?
Yeah, I don't think I had any more examples based on that. We're going to get to networking, but we're not going to do that yet. So let's go back to, and I'm going to just copy and paste. I'm going to copy this code, NeoPixel color from distance.
But this would be basically for any kind of sensor or something. So if someone has the standard PICO board and connects a sensor, then this is how they would
let me show you. Actually, I'm not logged in, but I'm tempted to copy. I'm going to open this in my browser off screen. I'm just going to copy and paste my current example for folks that do want to reference it.
Okay.
So I'm just going to copy and paste that, and then I can.
So you are going to add these.
That's right. I'm just gonna put it in this post. The edit button. I'll format it later. I just wanted to. I'm about to delete it or replace it, so I'm just saving it there, and I'll add it later. Okay, so from this post, and in fact, if I posts are as you edit them are live. So if we look just at the bottom, we should see that I've just pasted it in here. I'll move it around a little bit to go in the order that we're going, but now I'm going to copy this NeoPixel color from distance, and I'll show you the hardware that I've actually got plugged in here. So Adafruit has this standard called StemmaQT, which is for I2C. So on the device here, there's this plug on the side of the macropod that's kind of like the StemmaQT connector. It's an I2C protocol over here. And then this is the StemmaQT board here. So this is a, what's it say, VCNL 4200. And it says that on the back as well. This is a IR proximity sensor. So
do you know which one can we find datasheet?
VCNL
yeah
4200. Yeah, we can pull up the datasheet.
Oh, that's also the name of the sensor. I thought it's the name of the board or something.
It's the name of the sensor. So, sorry, I don't have search set up in Chrome. So, I searched for it. Here's the board that I have plugged in. And in fact, I'll show you how to get the datasheet from Adafruit. It should be. It might be here.
Technical details, maybe.
Yeah. The other place to look. So Adafruit products on the shop are usually linked to their Learn Guides. So I've showed Learn Guides already, but you can start from the product and get to the Learn Guides that reference it. So here's the tutorial on how to use it. And it's got CircuitPython example code. Shows you how to wire it up. This Python library also is able to run on Raspberry Pi, so you could use it from Linux as well. This is how you would install it on Linux. If you're doing it from CircuitPython, you drag these files over, is what it says. Which I'm kind of surprised. And in fact, maybe we should do this. So project bundles on the Learn Guide, this includes all the libraries by default. So if we just do download project bundle, examples 1, open it up, and it's given me a CircuitPython 8 version and 9 version. So I'm just going to do the 9 version and try to extract these here. We'll see what we get. Whether it did, I think it did all of them, unfortunately. Oh, no, it did. So I'm gonna cut these and put them here. We're gonna write into lib, and we're gonna overwrite our. Do we want to overwrite? No, we'll skip overwriting CodePy. So what that brought with it is NPY versions of these libraries. So this is the not human readable version of the library. It doesn't even know how to open it.
That's the driver for the sensor, yeah?
Yeah, so it's an optimized version of the driver. The source code is still available, so if we do GitHub, Adafruit, and then the VC and L 4200, I think that's what it was. Yeah, so here's the repo for it, and here's the Python code that has been changed a little bit to be more optimal for loading, but it's still, the source is available. And now our example is actually running. So let's show our example. So we're doing NeoPixel, board.neopixel like we did before. We're getting the I2C bus, so we do board.stemma I2C. This is kind of a standard name we have for the I2C bus. That's the one with the plug. There's also, you may also have a board.I2C if it's just SDA and SCL that have been designated. We create the sensor device here. And then in a true loop, we're reading the proximity. We're printing it out. So this is a Python thing called f strings. So you say, hey, this is an f string. And in curly braces, you can put the variable that you want. So that's how we're doing like the string printing. And then we're doing pixels.fill. And we have this built-in module called Rainbow.io, which just takes a number between 0 and 255 and produces like RGB value of the hue. So if we move it so you can actually see, so it's actually, well, it turned blue. It was yellow, so right now it's pointing to the thing. So I'm going to point it to the ceiling. And you can see my values are zeros and ones. And I'm just going to move my hand and get closer and closer. And the color is changing as I get closer and further away.
Okay, now I have a question. So basically now we are talking to the sensor on level of driver, but how can you talk or access I2C directly?
Yes, so this is using a driver, but if we
let's say I guess the sensor will have some kind of ID or something. Can we read the sensor ID?
Right. So if we do import board, and then we do we'll say I2C equals board.stemma I2C like we did before. We can do an I2C.scan. And so there's locking around this, so we're going to do try lock. The driver handles this for you. So we've locked the bus, so we're the only ones that can use it. And now we do a scan, and we're getting 81 as the device that's on the thing. If we looked at the data sheet, which we didn't find, but we could find, well, we should find that that's the address of the device. And in fact, we could see in the driver, Adafruit BCNL 4200, I2C address const 51 in hex. So if we do hex of 81 is 0x51.
Okay, so we found device on address 51. And how can you read specific register on this address?
So if we do dir I2C, we'll see the API that we have. So we have read from, write to, then read from. So usually that's what you would do is you, it depends on the device, but you would say, hey, write to, you know.
Yeah, I know. Well, sometimes you have to write the address where you would like to read from.
Right.
Because there is only one register sometimes.
Right. So the best place to look is docs.circuitpython.org. And we're doing, it's a bus.io I2C object. And in fact, if we do type of I2C, it should say, it says I2C. It doesn't tell us it's for the bus.io module. I don't know how to get it to say that. But that is what it is.
Okay, we need to find the datasheet. No.
Okay, so this is the example code. Sometimes it downloads. So yeah, here we go. So downloads, here's the data sheet, the EvoCAD PCB files, the fritzing object, and the schematic for this is just the sensor breakout schematic. And the dimensions and stuff. So here's the data sheet. Bus timing parameters, address byte, command code, data byte low, data byte high.
Maybe we are not going to do it in this example because
no,
we don't have
it gets complicated. This gets complicated. But this is what's happening under the hood for the driver.
There, I see there. Go down, a little bit down. Here.
Right.
Receive, send, receive. Yeah.
Yeah. Address, command code, data byte low, data byte high. And I could show you how it's done in the driver. It's a little complicated. So in Python, you have these things called data descriptors. So there's a lot of these private variables that use these read-write bits. So it says what how many bits it is, what register it is, and it's doing all of the I2C transactions for you when you're reading and writing those values. So in the driver, that's how they've implemented it. Is they've said like they're mapping like the commands on the data sheet to variable names, like properties of the driver class for you. So like
maybe we choose too complicated sensor for this example, but this is at least to give idea everyone how to start with I2C.
Yeah, so docs.circuitpython.org, although I bet the Essentials has it as well. If we look at CircuitPython Essentials,
there is I2C, I can see it.
Yeah. Right. So this will be more tutorial-like rather than just an API interface for you. So you can see like try to lock it. So this is in case of like if there's a display that CircuitPython is using over I2C, it's making sure that like only one person's using it at a time. This is just the scan, and then this is just using a driver. CircuitPython is very dynamic, so there's a chunk of code here that allows you to figure out all the different pin combinations you can use for another I2C bus, which can be handy and something that people don't always understand that CircuitPython is that dynamic. So I've shown it with board.I2C, but you could actually use a lot of different pins for your I2C bus if you want.
They can be mapped to different pins.
Yeah. You could have multiple of them going at the same time, and that sort of thing.
Okay,
if it's not possible, we'll just raise an exception.
What is next example? Because we don't
so
have too much time. I really would like to see also the Wi-Fi or Bluetooth or what we have there.
And I think that's the last thing we've got here. We did typing stuff. We did NeoPixel. We did I2C. So the last thing we wanted to do is show a little bit about the Wi-Fi thing. So I'm going to stop using the MacroPad and go back to the PICO 2W. I'm just going to unplug it, although I should have ejected it first to be friendly to it. But I've got backups of all that code. Okay, so I'm going to plug the PICO 2W back in.
There is our Blinky example running now.
My USB cables do not like the small dev board. Okay. Okay, so it's blinking. The MacroPad's there just to hold it down. So I'm going to take advantage of the fact that CircuitPython will automatically connect based on a settings.toml file. But I'm going to copy a version with my Wi-Fi credentials rather than this is just the example.
Yeah.
So if I open it here, and I don't actually care if you see it if I accidentally show it. But
you are going to change it after recording.
Right. So I'm gonna look in my backup files. I have this folder called random backups. Sorted right, random backups, and then I have this backup here. So this is 114 bytes. That's just got my Wi-Fi credentials in it. So I'm going to copy that over.
Okay.
And I'm going to overwrite it. And I'm going to eject it because my intention is that it would get on the Wi-Fi automatically, but I don't think that's working right now. So I've got to actually unplug it and plug it back in. So I ejected it to make sure it wrote everything to the file system. Now I'm just going to unplug it, replug it in, and we'll get connected to the serial and see what it says.
Oh, it stopped flashing. Oh, it started flashing again. Yeah, okay.
Yeah, sometimes that can happen if while your computer is like mounting the drive, it may actually write to it. And that will cause it to do the auto reload. So the auto reload is not super smart. It's just any write to the file system with like a cooldown timer on it so that it doesn't happen constantly. So that's why you saw it like pause and then continue again. that was my computer doing something to it. So now it's here. We have Blink open.
Go back. I would like to see. So now there is the extra file with the credentials for Wi-Fi, correct? On the drive.
Yes. Yeah. So settings.toml was empty.
There are only 3 lines, what we could see in the example. Yeah, the name, password, and what was there?
Yeah. So the last thing there is web API password.
Mm-hmm.
So there's actually a full web API to the CircuitPython device that has been connected with this and has this third line. So if we look at our serial, you'll see that there's a little Python or snake emoji. And then now, because we're connected to the Wi-Fi, it's actually giving us an IP address.
Oh, so we are not connected through.
So we're connected over USB, but we are also connected to Wi-Fi now.
Oh.
And in fact, let's see if I can get my. So if you go CircuitPython.local. So we've connected to the board. It says, hey, you're connected to a PICO 2W. Here's the host name, and here's the IP that we saw on the serial network.
So this is the website running on the board.
Yes, so this is like the native CircuitPython web page that's running. And we can actually go to the file browser, and here it's asking us for a password. So that's what that third line is.
Mm-hmm.
If I type hello, which is what my password is, it should load. I can see it spinning. I did not try this beforehand, so.
Mm-hmm. And basically this Wi-Fi will automatically start, and the server will automatically start when you put there the credentials?
Yeah, when you do settings.toml.
Mm-hmm.
So it took a while. I'm not sure why it's that slow, but it did show it's showing me the same file listing.
Mm-hmm.
And it is giving me this heads up that says like, hey, like you're connected over USB. We can't modify it from here right now. Because USB is really low level. And so you can't do like file level modifications. It's doing block based. So that's why we can't currently edit it there. You can also actually, I think this is really cool. So you can also, if you do the full code editor, it pulls up this, which is able to open it
again. You can change the code over the website, over Wi-Fi.
If we weren't connected over a USB right now, we would be able to.
Cool. Okay, so now what I would like to do.
You can also see the serial.
What I would like to do with Wi-Fi is control LED.
Yeah, so I have one other step that I wanted to do before that, which is just a request. So here, I'm just going to copy this code, and I'm going to go back to using it over USB.
Mm-hmm.
And so what I'm going to do is Adafruit just has this Wi-Fi test page. So I'm going to hit save, and there's a couple things I'm going to need to install. Connection Manager and Adafruit requests. So I could do it with Circup, but we've been doing bundle. So let's go to the bundle, the live, and sort by name. We need Connection Manager and requests, which are just single files. So we're going to drag Connection Manager over, and we're going to drag requests over. You can see that it actually ran again.
Yeah.
Missing requests, and now we get this is a test of Adafruit Wi-Fi. If you can read this, it's working. So that's great. So we've done an HTTP request over the web, over the Wi-Fi that automatically started for us. And then you wanted to change the link.
Go back. So what does it mean we did HTTP request? So we can access websites, or what is it?
Right. Yeah, so so Adafruit requests is like the requests Python library, which is doing a GET request. So you're creating a session, and then you're doing requests get this URL, and then
Mhm.
you're printing the text of the response back.
Mhm.
But you
So-
could imagine it's like, you know, a weather API or something that you have a server for, or any HTTP request.
Mhm. If you would like to show news or tweets or something
Right.
on the board, then you can basically use this
Yeah.
get command to
Right.
access your tweets through API
Right.
or something, and then show them on the display of this board.
Right. Or you have like a circuit, or you have like a GitHub repo that is what, like, your macro tag configuration, right? Like, and every morning at 8 a.m. before you get into work, it like fetches the latest configuration or something.
Yeah, okay. So this is one direction of communication, but we
right.
also,
so this is getting something from another HTTP
yes.
server.
Okay.
Now, there's this more complicated example for being an HTTP server that I've slimmed down here. And so I'm just going to hit copy code. I think I copied it.
So now we are going to rewrite the server which shows the files on the
So this is a second server.
second server. Oh.
So now we're running two servers after we copy HTTP server over. We're grabbing a lot of libraries today. So a different HTTP server, I'm just going to drag and drop. So it copies over, it's not small. So now it says that it's listening on port 5000.
Mhm.
So the one we were on before, we were on 80, right? The default HTTP port. But if we go to what it says, we get this page. This is a PICO W2. I didn't put a 2 in there, but it's a 2. Running an HTTP server with CircuitPython. And I can click on.
It works.
And the LED,
it works.
it's kind of hard to see. It turned on, and I turned off, and it turns it off. So
let's
this
have a
is
look
doing...
at the code. I'm curious.
Okay, so let's take a look at the code that Liz wrote. So credit to Liz who wrote this code. I slimmed it down. There's other stuff that the original example does.
Mm-hmm.
So we're doing IP address, Wi-Fi, socket pool. This is like socket, but for a specific networking device. We're setting up the LED. So this is similar to what we did before. Or.LED, setting the direction and the value. We're getting some sockets, and then we're starting an HTTP server here.
Mm-hmm.
Font family is just to change the family. So this is the
This
web
is the
page
website
that's being served.
Mm-hmm. So
yeah,
that's where you
so
can
say,
change. Yeah, you can change it.
Right. So if we wanted to say 2W, and we could have made it
Also up one. Yeah.
Yeah, we probably missed it. So we'll hit save. So when I hit save, it's going to restart. And then in Chrome, we will re-request the page. I don't know why it's costing me about form submission, but now there are 2 W's. So we've restarted the server. And actually, if we have the other server open still, we can still do CircuitPython.local trick to get.
You can put that IP and AT, so everyone can see. Basically, it's same but different port.
Yeah. So let's copy this. Paste.
It rewrite that number.
It did. I don't want to switch to that tab.
Okay.
Yeah, so there's 2 different HTTP servers running right now on CircuitPython.
Okay.
The user one and the internal one. And the internal one is because of this web API password. If you omit that, it won't start up. You could actually also do, I think, CircuitPython local will work with the other port.
Works.
Yeah, looks like it worked. Cool. So like
go back to the code. I would like to see where.
Okay, so that's all of the static stuff. So the HTTP server is using decorators to mark routes, right? So if it's a GET request on the root, all we do is we form a response with the contents of whatever web page returns. right? So that's how we're getting the regular page. If it's a post to the root, then we call this button press function. We read what the request included. And then if on was in the raw text, we set it on. If off was in the raw text, we set it off.
Oh,
And then we respond with the web page again.
that's not difficult.
No, it's quite simple. I mean, the whole thing is 124 lines. So those are like route handlers. And then we say, oh, we're going to start the server. We call start. We tell like what IP and port we're running on in the serial output. We catch OS errors, but there was some other error that caused it to stop. Broken pipe, I think is what it was. So we could add like broken pipe here. And it's pretty hardcore. It's resetting the whole microcontroller. So like USB would come down and start all the way back up. It's a way to just keep it, catch something and just start from scratch completely. And then it also has, it's actually doing pings to, this is like a Google DNS. So it's pinging that every 30 seconds to just be able to say whether it like lost internet access over Wi-Fi or not.
Cool.
And then you just call poll over and over and over again to read incoming requests and respond.
So this was the last example what we have on our list.
This is the last example that I put together.
But I hope we covered all the essentials, and I really hope now basically everyone can start from this and
totally.
And maybe add new drivers, add new sensors or something. Perfect.
Just do things with it, right? Like I think we've really shown like how powerful the workflow of CircuitPython is. I think in my mind of like it's just a drive, you edit the file, you save it, and it keeps going. If you have libraries, you drag and drop them over, and yeah, just a glimpse at all the different things that you can do with it.
So what do you do? What's your job?
What do I do?
Yeah.
So I work for Adafruit, which is open source hardware and software.
I could guess.
And I work on CircuitPython. So I started working on CircuitPython 8 years ago or so. CircuitPython is based on MicroPython, which is does a lot of the work about the Python side of things. We focus more on new platform support and consistent APIs across all of the platforms, and also workflows. So like the website where you can edit the files and stuff, that's all CircuitPython. That's not MicroPython. The save a file and auto reload, that's CircuitPython, not MicroPython, for example. But I got hired by Adafruit to bring MicroPython to their stuff, and then we looked at it and thought like we could improve on something that was already awesome, and that became CircuitPython.
Okay. So I would like to clarify. So the MicroPython is kind of generic Python for all the kind of microcontrollers.
It's one flavor of it. Yeah, it's Python for microcontrollers. Like they really focused and did the innovation on the like you have Python source code and it gets parsed and changed to bytecode and then executed. That's all MicroPython. And they have their own I2C API, for example. But when I was looking at it 8 years ago, it was not consistent across different chip platforms. And one of the things that I knew we were going to do is a lot of device drivers. So in CircuitPython, what we do is we have a standard I2C API that then is internally standard C functions that get implemented on every chip family.
So CircuitPython is basically your kind of software which supports all the kind of boards what you have.
Yes. It's our take on how to do Python on microcontrollers, like workflow, device APIs, that sort of stuff. The VM itself is pretty much what MicroPython.
So it can be used on any kind of microcontrollers, not only on your board. That's what you are saying.
Yeah. Like we wanted to make it the experience that we wanted for Adafruit's products, Adafruit's boards, but we don't limit it to just Adafruit's software. What you may find is that folks like me that are funded by Adafruit, most of our energy goes into supporting Adafruit hardware.
Mm-hmm.
But that doesn't exclude other folks from adding other things. Like the Pico 2W we sell, but we don't make, for example.
Mm-hmm. Or
And we just look
I2C
in,
support, it can support all the kind of I2C sensor, not only yours,
right,
but
right.
basically
You
what
may
you
not
do,
find a you may not find an Adafruit driver for something that Adafruit doesn't sell.
yeah, that's
But
what
we
I
also
mean.
do have we also have a community bundle that has drivers that the community maintains.
Mm-hmm.
And you can use that too. So seed boards, waveshare boards, lots and lots and lots of different boards that we support. You know, a lot of the work actually goes into supporting the microcontroller, not the board itself. So as long as the microcontroller is supported in CircuitPython, like it's not too hard to add support for a new development board.
Okay. I wanted to, before we finish, I would like to say this is not sponsored, okay? It's not
No.
sponsored. I just was curious because I have the PICO board, I've done keyboard, and I know Python is very popular now. Everyone is learning Python. So I thought it would be really great to create this kind of video to show people how easy it is to start with these very cheap Raspberry Pi Pico boards, and especially because they are becoming more and more popular. So that's why I contacted Scott, and I'm very thankful for helping me to create this video and spending your own time preparing all the examples. Thank you, Scott.
Yeah, thank you. And thanks to Adafruit for sponsoring me to do it. Not you, but I am being paid to do this.
Okay, thank you, Scott. Yeah, if anyone has any questions, they can leave them in comments. And if they have any ideas for maybe next follow-up video, then again, leave comments. Thank you.
Sounds great. Thanks for having me.
And that's everything. Thank you very much for watching this video. By the way, we are preparing some very interesting tutorials, so if you don't want to miss them, hit the subscribe button. If you want, you can also check out our FedEval online courses, where you will find everything important from basic board design up to advanced hardware design and PCB layout. The link is in the description. That's all for this video. Thank you again. Don't forget to leave your comments and see you next time. Bye.